Hello, everyone. Welcome to Pi Day. It is 1:59 on 314. For those folks who are using the other date system, we'll probably be back in mid-July for Pi Approximation Day, which I think is like July 29th or something like that. That's not right. It would be, well, anyway. So somewhere in the middle of July is Pi Approximation Day for all you folks who are not celebrating it today because of the difference in date structure. But guess what? Today we're going to have an awesome time. Maybe in mid-July we'll have an awesome time too. And let's check out what we've got on the desk here. So this is... very excited about this. Ooh, and we're frozen. Alas. Let me change this up just a second. So we can actually see stuff. There we go. Live action. A little bit more dodgy focus, but that's fine. So we've got this beautiful little MacroPad from Adafruit, and I'm so excited to dig into this. It is a 12-key MacroPad based on the Raspberry Pi RP2040 chip that's right up there, and they've got a little QSpy flash on there as well. Oh, that's really flat. Interesting. It's got a little buzzer on it. It's got a reset button. You've got a little display screen, an OLED. You have a potentiometer, or rotary encoder, actually. It goes all the way around and around and around, and it just like measures how much you're turning this knob each way with an integrated button in it, which makes me very happy, and that's how you make the bootloader go. And I'm going to be assembling it today with these keycaps and switches. I haven't personally done a lot of keyboard stuff, custom keyboard stuff, but it is getting to be a really popular hobby. And so I started making my own one. This is just a prototype with some leftover proto board that I had around. This is SparkFun's snappable proto board, which I love. But ignore all this, it's from previous projects. But I was trying to make a little keyboard to help rescue my Mac computer and help it become alive again. But I decided that for Pi Day, we'd just do something really quick and easy and put together this MacroPad. It doesn't even require any soldering. My mistake when I was drafting up some of the tweets, the first one was like, we're gonna solder this together. It doesn't even require any soldering, which is incredible. You just snap everything together and then you plug it in over USB-C, and then we're gonna do a little bit of programming in CircuitPython to tell it to be a keyboard, and we'll go through their whole tutorial and take a look at what that looks like. And along the way, we'll take a look at some other fun Pi RP2040 stuff. For example, this bunch of chips that we have from when they first released the RP2040 chip. Super cool. Oh, Yanni says appropriately, yes, in June is Tau Day. So that would be June 28th, because 6.28 is twice 3.14, and some people think that that should be the actual unit that we use for a bunch of stuff, because frequently you're saying 2 pi r, etc., and you should just use tau instead. So anyway, let's get going with this. First, we're going to take a look at the product page. I can't stop like touching this thing, even though it doesn't have any keys on it yet. I can only imagine how fidgety it's going to be once I actually get it together and start doing stuff with this. Okay, so here is our Adafruit MacroPad product page. It's out of stock. Cry. Boo-hoo. It's very sad. But as you can see, there's this USB-C slot there. Let's make this a little smaller so it shows up. Yeah. All the stuff that we just talked about, a back view of the board with a 1/4 scale, and you can check out the whole full info there. I've gone through this overview, and so hopefully this should be pretty smooth sailing. They go really in depth on this, so we're not going to cover everything in the overview, but it is a really nice bottom to top explanation of lots of the things that you're going to be using. For example, the Mu editor and stuff like that, which is their recommended editor for CircuitPython. You don't have to use it if you already prefer a different code editor or IDE, but you can, and that's what they recommend, and that's what this tutorial covers. So features: RP2040 chip plus 8 megs of flash memory, QSpy flash, and you've got a USB-C connector for power and data. Wait, no. And 3x4 mechanical key switch sockets array, And the way that they mentioned sockets here, you don't have to solder the keys in. You just connect them to these sockets with a couple of little contacts that you push into there. And that makes it really easy to swap out keys if you want to try a different weight and stuff like that. We'll get into that later. Yeah, good stuff. 1 NeoPixel RGB LED per switch, so like you can see it's all lit up here. Here. You can write animations for those and have it respond to stuff. Rotary encoder, 20 detents per rotation. So, if you rotate this thing one full turn, you will feel it sort of click into place 20 times. I'll just take their word on that. Yeah, and back to our page. Let's see. A monochrome OLED display, 8mm speaker / buzzer with a Class D amp and RC filter. Cool. Simple beeps and sound effects. Chiptunes, maybe? I did a video the other day on pocket operators, which are little pocket-size calculator type synthesizers, and I think that this could be a cool way to like prototype your own pocket operator-esque music devices. And you'd be using like controlling stuff on your, you could either use it to control stuff on your computer using it as an HID device, a human input device. I guess device is redundant there. Or you could have it be standalone. Who knows? Stemma QT connector. This is Adafruit's equivalent of like Seed Grove or SparkFun Quick. They're sort of custom little connector for plug and play devices for sensors and outputs and stuff. Reset button and 4 M3 mounting bosses. I'll show you that as well. So these are little standoffs with threads for for M3 bolts or screws. And I do have some of those here, some black nylon M3 bolts. I'm gonna have to peel these stickers off, which is a bit of a pain. They're like covered in Kapton tape. Grrr! Grrr! Well, anyway, I've got these and I've screwed some little M3 nuts onto them as well so that they will stick out and stay stable and be adjustable in height. Here we go. So something like that. Gotta make sure it's not cross-threaded, especially with nylon. But yeah, you can do that. I'm probably gonna do that at the end. Let's get into the tutorial time. You've got pinouts, all this wonderful information. I'm not going to go through all of this because you can look at this yourself. Keys by flash, red LED. There's a programmable red LED up near the top at the back near the USB-C port right here. And that too is user programmable. So you can do that if you want for different types of feedback. Imagine if you were like in editing mode versus read mode for like a text editor. Could be useful. Reset button, mounting bosses, etc. MacroPad assembly. They've got a video of assembling it. This features another cool thing that they've got on their site. Where is it? Somewhere in here, they've got like a 3D printed stand for it. There's lots of stuff on the site about this. Here we go. By the Ruiz brothers, who we had on the show a while ago in 2021. But they've got this beautiful little printable stand that has like hinges that print in place. Beautiful. There are extra pieces that you can get for this kit. I did not get them. This is the bare bones kit. There's a couple of extra PCBs. There's one that goes on top that you can snap the switches in for some more mechanical reinforcement. I'm thinking I'll probably just 3D print my own plate for that, if I can figure out exactly the dimensions for it and stuff. The keys will snap into there, and then you sort of press them into their sockets as well, and that way it stabilizes the whole thing. There's also a decorative back plate that you can get for this that's really beautiful, designed by someone called Paint Your Dragon, that has this Voyager imagery on it. Let's see where that is. Here we go. Yeah, the hardware add-on pack. Look at this. With the golden record. Oh, it's beautiful. Devise your own paths. Anyway, good stuff. I did not get that. So I'm going to skip this step where you stick the switches into a plate. But I'm going to go ahead and connect these to the board. I think that it will be fine mechanically. I'll just be a little gentle with this. You don't need the stabilizing plate. It just helps. As far as I know. Maybe it'll explode. If it explodes, I guess we'll know that we need the plate. So this is why I do it first. Alex Glow, taking on the possible explodey hardware projects, so you don't have to. I'll be the guinea pig. Okay. So, there's a couple different ways that you can do this. You can either put the caps on first and then press them into the board, or vice versa. I'm going to put them on the board first, partly because these caps have, I didn't check this out before, but it looks like they're all directional? That's strange. Okay. You can see, oh no, they're symmetrical sideways. They're just like angled so that the top is flat and the bottom is angled, which is aesthetically pleasing, I guess. I thought that they were like some of them were corner ones or whatever, and I'd have to organize them all, but no, I'm just going to arrange them so that the flat part is on top. And then we'll be all set for sticking them on later. There's 12 of these. They come in a 12-pack. You can get various numbers of these. If you want to make your own custom keyboard, which I am planning on doing, I've also ordered a bunch of different numbers of switches and keycaps for doing that. You can get clear keycaps. You can get these ones that are relegendable, that have like a gray base and then a clear case that snaps on over them, and that way you can sort of sandwich a label in between. There's black ones with word labels on them and stuff. Let me see if those are around here. Well, they're on the Adafruit site. Here we go. Black pudding keycaps, and they've got stuff like, if you want to use this as a numpad, if you don't have one for your computer, you could add a numpad onto your computer if you get these ones. Let's go back to assembly. Okay, cool. So I have got a bunch of switches. These are Kale chalk switches, and they are red type. That denotes something about basically how clicky they are, how intense the spring is, like how hard you have to press. Some of them have like a click feedback, others don't. And so these are ones that I like. I've tested them before. And I'm just going to go ahead and match up these little contacts to the holes, the sockets in the board, and stick them in like so. So as you can see, you don't need the front plate. It would be nice, and it looks nice, but I'd rather 3D print my own. So I'm just going to put it together like so for now. And then later on, I might pull out the switches and put a front plate on when I've 3D printed one. I'm going to use that quantum filament from Matter Hackers. That is so pretty. Go in there. Okay, so we start by just pressing all of these into place. And if you look at the description to the video, I've got links to the tutorial, to the products that I'm using. There's all kinds of good stuff there. The tutorial really has a lot of good stuff to dig into. Ooh, I keep being worried that I'm like missing the socket on these. It does take a little bit of force, not like a huge amount, but don't be afraid to like jam it in there, I guess. Hello, Kevin. Hello, Adam. Nice to see some familiar faces in there. In the chat. Okay. Thanks for joining me on this Pi Day. I would have done, 3.14159, what is it, 2653, something. We could have done it at, we're doing it at 1:59, which is, 1:59 p.m. We could have done it at like 3 something military time, which would be like 1500 hours and get another digit in there, but also there's no like 9 in the tens place for minutes, so it's got to be 1:59 p.m. Could have been 1:59 a.m., but I'm not that dedicated. I'm sorry, there's some things I will do for you, Hacksters, and others that are a little bit out of spec. Dude, oh, this is so satisfying. Do you remember how I was already fidgeting with this before I put anything on it? Oh, dear. Okay, so these are going to go on like this. And you can see there's a little plus sign in there, and there's like a plus-shaped hole in here, and a little round guy. This all just sort of pushes together. It takes some force as well. Oh, man. Oh, Timon! Hello! Timon does a really cool... Speaking of Pi Day, Timon creates the Pionora kit, which is basically like Raspberry Pi for people who like Arduino. It's a mounting board for, or a carrier board for the Raspberry Pi Compute Module 4, and we've done an interview with him last year. It was really cool. I think you're working on a new version of that, aren't you? Oh, this is so satisfying. Wait, am I missing some? I might have to grab some more of these. I've gotten like a spare bag somewhere. I think this was just a 10-pack. And I thought I counted them before I started the stream, is the annoying thing, but don't worry, we have backups. They might be shorter, though. Oh! There's no way to make it aesthetically pleasing if 2 of them are shorter. I could put them in the middle. Well, let's see. Where are my extra ones? See, they're a slightly different profile. Should I put on 2 of these beige ones? Ugh. Humiliating. That's fine. Maybe I'll leave 2 of them off just to see what it looks like. No, I will put on 2 more clear ones. And you'll just have to bear with me. Okay. So here we are. More little clear key packs. So this is a 12-pack. Somehow the one that I got was a 10-pack. I might pull those off later on and just like stick all of these 12 ones on, because plus they're a little bit lower profile, which I actually kind of like. So, oh! Beige ones over there. These guys over here. Forgive me for, I know I am making a terrible choice right now, but we gotta get through the video, so I'll update it later. Oh, those are a little easier to put on. Oh, that is so satisfying. Tommy says, Happy Pi Day! Hey, Tommy! Tommy's the creator, if it is the same Tommy, in fact, the creator of the Oscatone synthesizer DIY synth, which is also really cool. Looks like this. Woo! Oscatone Scout. For people who are interested in little musical electronics. Very cool. Now, let's look at the next level of the tutorial. They talk about the backplates and stuff. Oh yeah, we could put some M3 screws on there. But given how annoying it was to get that Kapton tape off of the first boss there, I am not going to face the other bosses just yet. CircuitPython! So they tell you to use the Mu editor. First, you've got to get CircuitPython running on your board. So I'm going to take my data cable, my USB-C data cable. This is a not just for charging, it has power and data lines. Sunlight's kind of getting on me now. And I'm going to plug this into, it's plugged into my computer, and I'm plugging it into the MacroPad now. And I'm going to take this sticker off because it'll be satisfying. Come on. There we go. So nice. We're going to plug this in. Doop. Adafruit, DigiKey. Adafruit, MacroPad, rotary encoder 0. Oh, interesting. It goes negative when you turn it to the right. And this isn't going to show up great on the video, so I can just tell you what it's doing. And it says I2C scan as well. And, oh, it's spatially mapped! And you can do corded key presses. Okay, this is really exciting to me for various reasons. So it turns white. Each one turns white when you push the key, and it shows you a little spatial display of which ones you're pushing. If you're not familiar with corded keyboards, let me show you a really cool custom keyboard someone is selling online called the Georgie. This is for stenography. So the idea is that you press like multiple keys at once, and each letter that you press is actually like a combination of key presses. Usually, some of them are like a single key, like A over here, but some of them are like, you gotta press these 4 at once. And so they're a really light touch switch. But this is just another example of a cool sort of DIY hardware community keyboard option. It's so rad. If you're not aware of modern stenography, you should check it out. It's just a way of like being able to type really fast, basically, and like hundreds of words per minute if you get really good at it, which I'm not. So anyway, this has corded key presses, which is nice. It will like detect two keys being pressed at the same time, and these are, I think they're like GPIO 1 through 12 rather than like 0 through 11 or anything. CircuitPython Quick Start. So I'm going to put this in bootloader mode. You use the boot switch, the rotary encoder switch for this, the button here. Boop. Oh, cool. That's really neat. Okay, so I'm gonna hold this down and push reset. Boop. And now it should be in bootloader mode. And now what I'm going to do, following this tutorial, is I'm going to drag the .uf2 CircuitPython file onto this rpi/rp2 drive that's just shown up on my computer. So I've downloaded a .uf2 firmware file from this tutorial, and now I've just dragged it onto the drive. And it should reboot and come back up as CircuitPython, as a drive called CircuitPython. Or CircuitPy maybe. Okay, it did eject itself. That's good. I might have to hit reset before it comes back. Here we go. Hello world, code done running. Cool. I'll show you this. It's got a little blink CircuitPython up on there. I did get a notification from macOS that it wants to know what kind of keyboard this is. So I'm going to... Hello, I'd like to see my windows, please. Well, I'm going to go have a look at my windows and tell it that it should just chill out, and it's fine. Mac always wants to know. There we go. It says your keyboard cannot be identified and will not be usable until it is identified. To identify this keyboard, click continue. Continue. And it says if your keyboard is working properly and you have an additional USB input device connected to your computer that is not a keyboard, you can skip this step. I've generally gone ahead and just skipped this. There is no shift key on here. So, and I've been able to get tests up and running on the Pico, which also uses the RP2040 chip, without having it be able to identify my keyboard. So no worries there if you're on a Mac. Yeah, it's definitely in my eyes right now. Okay, so, well, what's next? We've put this onto the board. And now it's running CircuitPython. And they have a bunch of information about different weird modes that it can get into, how to use it in safe mode so that you can sort of get your code off of the board or modify it and stuff if you have issues. There's also a flash resetting you have to, in case you just really mess stuff up, and that you can just drop onto there. Now here's the Moo editor, Moo, whatever. You're either a cow or a cat, I guess. And once you start it up, it should detect if you have a CircuitPython device attached. So I'm going to go ahead and do that. Fire it up. And try and give you a view onto that as well. Okay, it did not ask me if... oh, it did! Okay, so I'm going to stop showing you this window. And instead I'm going to show you the editor. Here we go. Okay, cool. So this is an example piece of code that they've got in the tutorial. This is just like import board. These are importing libraries or modules that you use. Oh, whoa, it goes away when I highlight it for some reason. Strange display issues. Then you're telling it that there's this one red LED next to the USB port, in so many words, and then that it's an output. And you're going to print CircuitPython to the serial console and turn that LED on and off at a certain rate. Let me see. Do I have to? There we go. There's the REPL. Okay. let's first save this file. So this is saved as main.py. There's an interesting part in the tutorial where they tell you that there's 4 different, well, let's put this in dark mode. There's 4 different files that CircuitPython will look for, and they'll look for them in a specific order. I won't worry about dark mode just yet. So they look for them in a specific order, and one of them is main.py, but that's like one of the last ones that the code looks for. Firmware looks for. The first one it looks for is code.txt. If that doesn't exist, it looks for code.py. If that doesn't exist, it looks for main.txt, and then it looks for main.py. So usually you'll use code.py. In this case, I've named this main.py because I want to upload it to the board, but then later on I'm going to stick code.py on that board, and I wanted to have them have different names just because cleanliness somehow. So I'm going to go into my moo code folder, which it created in my home directory. Here we go, moo_code. And there is in the top level there is my main.py saved file. And I can drag that onto the CircuitPython drive that's appearing in my Finder here. So, oh, there's already code.py on there, of course. That makes sense. So what if I just delete that one or back it up somewhere? I'm going to put a new folder. So what I'm doing now is I'm in the CircuitPy drive that this keyboard appears as on my computer. And I'm going to make a little folder on there that says archive. I'm going to stick the original code.py in there just for safekeeping. And then I'm going to rename my new main.py to code.py. And it should write. And yeah, here we go. Code.py output. Hello, CircuitPython. And it should just keep printing that, basically. You may not see that because it's saying the same thing over and over again. And it's flickering on your screen. But yeah, that's cool. So that works. Exciting. And I don't think it's actually doing anything when you push the buttons yet. Oh, but it should be blinking that red LED. And it is! Look at that! This red LED on the back is what is blinking right now. And that's because of that code that we just stuck on there. Ha! Cool. And then if I want to, I can actually go back in and erase that one. And I'll have to reset it so that it shows up again. And Mew complained about that. It said, could not find an attached device, but now it's showing up again in my sidebar on Mac. So I'm going to go in and mess with that and change it back to the original file. Or actually, no, let's try some of the examples. So we're working in the Moo editor. I'm going to exit out of here for you again and show you the tutorial because there's some really interesting examples on here. Naming your program files, connecting to the serial console. You can talk to the, you can talk to the board directly through the REPL and get info off of the serial console. REPL stands for read, evaluate, print loop. It's all kinds of interesting stuff. I'm going to skip past this because it is cool, but we don't have time today to go through all of this. As you can see, there's a really ample amount of information. I like this one. It's just a list of all the different MicroPython modules that are available. And so these are all built into the library that you're using. So you've got an alarm module, you've got audio core, audio MP3, RGB matrix, Rainbow IO, fonts, image capture for some reason. I think this might just be built into the CircuitPython firmware, but yeah. Here we've got USB HID, that's for human input devices, USB MIDI for interacting with MIDI devices, SD card IO, Sharp display, etc. Math is useful for doing the obvious. And returning to the serial console, you can just print to the serial console and that'll appear in the bottom of your Mu editor. CircuitPython libraries, all kinds of stuff here. We just looked at a bunch of those. There's a number of different library bundles. There's the official Adafruit CircuitPython library bundle. There's also one created by the community, a bunch of libraries created by the community that you can run on your CircuitPython devices for various things. Very exciting. And then those have their own example files. They tell you how to copy those to your board. But I think a good place to start, what I'm about to start with, is some... Well, there's also FAQs. Where do we actually get to the part of doing their examples? Here we go. So if you scroll down to MacroPad CircuitPython library, we get to the examples that I'm going to try running today. So we've got MacroPad basics, and this is just sort of like, when you're working with NeoPixel LEDs, often you'll run a sketch called Simple Test, and that just basically runs them through a bunch of different paces. And it's also a really useful example file that you can check out about how to do different types of animations and stuff, how to make the LEDs chase each other around, how to show rainbows, how to do little sparklies, etc. So this is sort of like that, but for this board. It just puts it through its paces and gives you some useful things to try in code. So let's try opening up one of those. There's one simple test. And for this, like I say, what you got to do is download the project bundle. You hit this button here, the blue cloud download project bundle button. And then there's going to be a zip file. And there's a bunch of different stuff in there, but there is a folder called lib that has a bunch of the required libraries. And then also there's a code.py file. So I'm going to drag both of those. All the library files, I'm going to copy the entire lib folder and the code.py file over to my little CircuitPy drive there. Doop. And I'm going to replace what's already there. It's taking a little bit, it's about 118 kilobytes, but this is going a little bit slowly. So while that's doing its thing, let's take a look at some more cool stuff. Okay, so here's the MacroPad that we're working with. Works over USB, beautiful. Here is the little Pi Pico keyboard that I've been hacking on. It's just literally soldered onto a bunch of buttons in a really janky way on a piece of spare, already used proto board, but waste not, want not. Here's some RP2040 chips. I can show you where our unboxing for those is. When we first announced the availability of those chips, you can find that on our Hackster channel, which may be where you're watching this right now. You can also find those on Farnell. You can find the Raspberry or Newark. You can find the Raspberry Pi Pico. You can find the RP2040 chips, etc. All kinds of cool stuff on there. More keycaps, 3D printed stand on Adafruit. There's a couple of different projects that you can do with these. They've got some tutorials. Back to here, let's do some more show and tell. So I told you about the Georgie keyboard that I was working with. This is the Stenography Keyboard that basically you press chords of keys all at once, and that types a letter or a word even. You can do a whole word in like a single set of key presses, which is kind of cool. This is a cool little documentation reference that Adafruit has that you can buy along with other things on their store. So if you're like buying some Pi Pico boards, then they may send you one of these as well if you choose it on the product page. It's very cool. I like having a little visual reference. It's small, it's nicely printed. It's a great thing to have on the side of your desk. Another one, this thing is still copying. Just a side note, another cool community developed keyboard. This is the Gergoplex. It's just a sort of what do you call it? An ergonomic keyboard, split keyboard made by somebody online, and you assemble it yourself. You have to like buy the keycaps. This doesn't come with switches or sockets or anything, so you have to actually solder stuff together. But oh yeah, it's by Jeremy Bernhardt, G Heavy Industries. And yeah, it's just got a really cool design on it. And I look forward to putting this together someday. I actually bought this by accident when I was trying to buy the stenography one, but it'll be a cool project at some point. that's about all the show and tell I've got. Let's go back and see if this is ready loading yet. Okay, it seems to be done. And I'm going to eject it and reset it. Oh, yep. Okay, it's saying some stuff. Encoder, 0, encoder. Oh, okay, so on this one, the encoder goes positive as you go to the right, unlike the other one, which went negative when you go to the right. That was the sort of demo code that I loaded on here first. Encoder switch false. If I push this, it says true. Doot, doot, doot. Very cool. And this tells you what keys have been pressed. It's interesting. This seems to be actually offset a bit. It's cutting off at the top of the OLED, and there's some space at the bottom. So I'm curious. But it'll tell you like which key pressed is pressed. It doesn't seem to handle multi-key, like chorded key presses as well. So that's interesting. But that's a little boring because there's no lights happening. Let's check out another one of the examples. This is not an example, this is a product. Here we go. So that's the MacroPad Basics one. And you could always change that if you want. MacroPad Display Text. Basically, it's another way of displaying text on here. I could mess with that, but I think I'm going to move on to displaying an image. You can display an image on the OLED. So you download everything, and then you copy the entire lib folder and the code.py file. But you also save blinka.bmp to your CircuitPy drive. So that's 3 things that you're going to put on there. Or rather, I'm going to do it right now. This might take a moment again. Where did my folder go? Curses. So examples, display image. So I'm going into here. Inside of this zip file, there was a folder called examples. And inside of there is a folder called MacroPad display image. And inside of there is a folder called CircuitPython 7.x and a README file. And inside of there is a license file, our lib file. Oh, interesting. MacroPad display image.py, not code.py. I'm going to change that. What? Code.py. And blinka.bmp. So I'm going to take code.py, the lib directory, and blinka.bmp and drop those all onto there. And first I have to reset it. So it'll show up. There we go. I'm not actually ending up using the Mu editor at all, but you can use it this is going to take a second, but not as bad, 55 kilobytes. Mu editor. Yeah, if you want to edit the code.py files or create your own, they recommend using this editor. It has got a built-in REPL, a read evaluate print loop, which allows you to talk directly to the device, and basically like it'll like talk back if you tell it to print stuff to the serial monitor. But also like REPL allows you to basically like write lines of code directly in a command line style interface, and it'll execute when you hit enter, and then you can like write more code and hit enter, and that'll execute. So it's a little different than like writing a whole file, loading it onto the board, or running it, and then like the file runs. A REPL instead allows you to like write one line of code at a time, and then execute that line, and then write another line of code, and then execute that line. Sometimes things like for loops, it'll have you write the whole thing before you execute it, but that's basically what the difference is. All right, this seems to be done, so let's take a look at what's happening on here. Yes, and there we have a picture of Blinka. Very exciting. It does nothing. It does nothing except display Blinka, but that's all we really need, isn't it? Now let's get some lights going. Hopefully the next example has lights on it. I don't remember what it was. It was, oh, you know what it was? It was play tones. So I'm going to drop that onto there. This next example here. It looks like that. Oh yeah, they have a rotation one. This is interesting. This is just built in to the library. As you can see, usually it's set up like this with 0, 1, 2 at the top and 9, 10, 11 at the bottom. But you can tell it that you've rotated the entire MacroPad 0, 90, 180, or 270 degrees and get it to recognize the keys in a different order. And that can make it really easy to write your own, if you don't necessarily want it to be interacting with it like this. Maybe you want the encoder at the bottom and the screen at the bottom so you can see it more easily in a different orientation. Or maybe you want it sideways for like a cyberdeck type, like Pip-Boy wearable type of thing. You can do that, and it'll be pretty easy using this rotation information. Sorry, I'm a dork. Not sorry. So that's an option that you have. MacroPad tone. So now all you need is the code.py file and a lib folder. So let's get that up and running. I'm going to drag these onto there. Symbol plays tone. It's got the same file folder structure as the other one I told you about. Interestingly, inside of here are a couple extra directories called MacroPad MP3 and MacroPad display image. I'm really curious about, I feel like this is just because of how they were putting together the tutorials asynchronously or something. Okay, this is going to be 118 kilobytes again. Let's scroll through these. And let's see what other options there are just while we're here, because I'm not going to go through any of the other examples since I haven't already downloaded them and stuff. I just want to make it quick and easy. The nice thing is about this tutorial structure is that, is that you can link people to a specific page of the tutorial, whether it's the rotation one or the tone one or this one, and each one of them has a little intro at the top of it that tells you what it's doing. So if you're like me and you leave 80 tabs open for 3 months at a time, then you'll still find it pretty easy to pick up where you left off. Keyboard and mouse. This is like typing stuff. Cool. So you're able to send HID commands to your computer, such as key presses, strings, consumer control commands, e.g. volume increase or decrease. These are ones that are not like type hello world, but rather like, those extra keys. And you can even do ones like command and shift and option and whatever if you're on a Mac, or Windows button or anything, and makes a debounced version of the rotary encoder switch available. What else? MacroPad MIDI! Oh, look at this! MacroPad MIDI tester demo. You can plug it into a MIDI device and do cool stuff. Patch select mode, CC mode, pitch bend mode. Ooh, cool. Turn the knob left and right to bend the pitch. This is totally a John Park thing. And then they also have information about how to set this up with the Arduino IDE. So let's have a look at how this works for tone stuff. I actually didn't look at the directions for how to interact with this, so we'll see what it does. Oh, yeah. Does this do anything? No. Okay, so I'm holding it to the microphone now. Hopefully you can hear that. Anyway, so they're like flashing each color and doing little beepy beeps while you do that. It's very cute. It's not always super responsive if you hit it really fast. That could just be me not having pushed the contacts in far enough. Yeah, interesting. I should also be trying not to touch the back on here. That's another bonus of having a backplate on there. But yeah, okay, cool. We have gone through a bunch of the examples on here. We've put together the board. Again, you can get different types of plates to put on here. I'm thinking of 3D printing one to like help stabilize the keys. Maybe 3D printing one of those stands that the Rees brothers designed. I could even just put some stand-ups on the back here, or use these little nylon M3 bolts with some nuts on there to create adjustable height standoffs. I'm very much looking forward to this, whether like using it as a standalone device, It's not quite as beefy on the sound as the pocket operators, but then again, those are custom designed for audio. This is more designed as a like human input device. Very versatile and runs on that RP2040 Raspberry Pi custom silicon chip. Thank you for joining me for Pi Day. This has been really enjoyable. Oh, I can't wait to. I think that it's really cool programming in CircuitPython because it stores the code on the board. And that is a real lifesaver when it comes to picking up old projects or when you're moving between different computers. Maybe you're in a different place, you're doing an installation or something, and you want to be able to modify the code a little bit. If you are doing Arduino, then I love Arduino. Let's put that right out there. I love Arduino. But if you're doing Arduino, you have to have access to the file on a drive or on your computer or something like that. And then you can modify it, and you have to like know which version of it you currently have loaded and stuff like that. Whereas with CircuitPython, it stores it right on the board. You can just stick it, attach it to your computer with a USB cable, open up the drive, take a look at the file on there, tweak it if need be, save it, and then it's updated. So I think that it has a huge advantage over Arduino in that respect. There's also a lot of cool stuff available for it. That said, you can program this in Arduino or CircuitPython. I think it's a really cool little addition to anybody's arsenal, especially if you're doing music stuff. I'm thinking about working with different DAWs, digital audio workstations, and sometimes they have hotkeys for specific actions, and maybe you don't want to memorize all of those, or maybe you just want to have them all accessible in a predictable way. And so this would be a really cool accessory to have for any kind of repeated computer input situation that you have. Anyway, fun! Thank you for joining me on this Adafruit MacroPad adventure. I know that the sunshine got a little bit in our way, but this is really fun! I can't wait to play with it more! It's good to see a bunch of cool, familiar faces in here, and happy Pi Day. We'll see you soon. Maybe for Tau Day or Pi Appreciation or Pi Approximation Day. I always think of it as Pi Appreciation Day because who doesn't appreciate Pi, honestly? Okay. See you, everybody. Hack on.